After watching this video lecture, students will be able to identify absolute zero and what it means with respect to particle movement. You'll be able to identify STP conditions and calculate gas law problems. So absolute zero is a theoretical construct, and basically it's a temperature at which particles have no motion. Now we're moving towards absolute zero, which is 0 Kelvin or negative 273.15 in the Celsius scale. But basically it's a point at which the particles no longer are in their constant motion. Another thing you guys need to be familiar with is standard temperature and pressure. Standard temperature is going to be 0 degrees C and 1 atm of pressure. These values are commonly used in problems, so when you hear that the conditions are at STP, you should know that that refers to 0 degrees C and 1 atm. You will need to memorize these and have them on hand for your problems. So in terms of gas laws, we're going to go ahead and start with the combined gas law. The combined gas law here is P1V1 over T1 is equal to P2V2 over T2. Basically what this is a relationship between a specific quantity of gas at different conditions. So I can take a specific quantity of gas at a specific pressure, volume, and temperature, and I can figure out how that pressure or volume or temperature would change if I changed one of the other conditions. So if I changed from 200 milliliters at volume 1 into, let's say, 500 milliliters for my volume 2, we can then see how the changes that we are applying to this specific quantity of gas will alter, say, pressure or temperature. Okay. Now, all of the other gas laws can be derived from the combined gas law. Basically, when you're dealing with problems, when you're at a constant temperature, a constant volume, or a constant pressure, all you need to do is take the combined gas law and cancel out that constant variable. Okay, so at constant temperature, I would cancel out T1 and T2, and I'd be left with P1V1 equals P2V2. This is Boyle's law, and you would use that to solve relationships where pressure and volume are the variables or the components being monitored with respect to that gas. At constant volume, you end up with Gay-Lussac's law. You end up with P1 over T1 equals P2 over T2, and that's because we canceled the volume components that we see in the combined gas law. And then lastly, at constant pressure, notice there's no pressure variables here. We end up with V1 over T1 equals V2 over T2, and that's because we canceled our P1 and our P2 from our combined gas law. So guys, if you memorize the combined gas law, you can go ahead and derive these other three based on the conditions. Now, in your practice problems, guys, they may tell you that you're at constant temperature or constant volume or constant pressure, or if they don't mention temperature, volume, or pressure at all in the problem, you can infer that the temperature, volume, or pressure is constant. Okay guys, so when we go ahead and approach our gas law problems, first thing we're going to do is write out all our variables. That's going to allow us to decide what gas law equation we should use. Okay, so they tell us here that we have a volume of gas that's 6.10 liters. Okay, so that's going to be my volume 1. Okay, so my volume 1 is going to be 6.10 liters. Okay, my pressure 1 is going to be the 2.79 atms. Okay, and my temperature 1 is going to be 24 degrees C. Okay, I've also been told that I need to find its volume at STP. So the volume that I'm going to be solving for is going to be my question mark. It's a thing I don't know. Okay, the pressure at STP is going to be 1 atm because I've memorized that value. Okay, and my temperature is going to be 0 degrees at STP because that's the value that corresponds to the standard temperature. All right, so now I have all these variables. I want you guys to notice you have two temperatures, two pressures, you have a volume, and then a volume variable that you're solving for. So we know that the gas law that corresponds to all of these variables in one is going to be our combined gas law. Okay, so we are going to be utilizing this equation. Now with anything, guys, of course, we're going to be making sure that we calculate our equation before we plug in any of our variables. Okay, so we know that we're going to cross multiply. Okay, that T2 is going to come up to the left and the T1 is going to come up to the right. Okay, and that would give us P1V1 T2 equals P2, V2, T1. Okay, and we want to get V2 all by itself. So V2 is going to equal P1, V1, T2 all over P2, T1. Okay, and this is the equation that I'm going to solve my corresponding or plug my corresponding variables into. Okay, so now before we plug anything in, we need to confirm and check a couple of things. First thing is we want to make sure that our units match. Okay, so pressure 1 here, if you guys look at it, it's an ATM. Pressure 2 is also an ATM. Okay, so those match. If they didn't, you would need to convert into corresponding units. Okay, and then we also need to look here at our temperatures. Okay, so anytime you're doing gas law problems, guys, you must be in Kelvin. Okay, so please make sure that you are plugging your temperature in only in Kelvin units. Okay, so no Celsius, no Fahrenheit. You must be in Kelvin when it comes to your temperature. So we're going to go ahead and add 273.15 to each of these. Okay, because that's the conversion. We're showing that work. Okay, so my temperature in Kelvin here is 273.15. Okay, my temperature in Kelvin here is going to be 297.15 Kelvin. Okay, so we've done the work for both of those, and now we have units and such that we can plug in. So if we go ahead and we plug in our values, okay, so we have our P1, V1, and T2 on top. Okay, so P1 is going to be 2.79 ATM, okay, times my V1, which is 6.10 liters, okay, which is going to be times temperature 2. Temperature 2 is 273.15 Kelvin. Okay, and that's all going to be divided by P2, which is 1 ATM, times my T1, which is going to be 297.15 Kelvin. Okay, we plug this into our calculator, and that's going to give us 15.644. Okay, significant figure-wise, guys, we're going to go ahead and we are going to use our measured values. We're actually not going to use the STP values. Okay, we got 3 sig figs, 3 sig figs. Okay, these would both have 3 significant digits. Okay, but again, we're not going to use standard temperature or pressure. Okay, so we're going to focus instead on the other measurements. So all of them have 3 sig figs, so my answer is going to have 3 sig figs. I can go 15.6 as my final answer there. Units wise, ATM and ATM cancel, Kelvin and Kelvin cancel. Liters is what I'm left over with, so that corresponds to a volume value. Okay, now they asked specifically for my volume in milliliters. Okay, so you can either use Kevin Hates dates, okay, and just move the decimal, or you can use the relationship, 1,000 milliliters to 1 liter, okay, and do your conversion and get 15,600. Okay, milliliters as your final volume answer. So again, guys, with these problems, you're going to write out all the variables. That's going to help you decide which equation you're going to use. You're going to manipulate that equation. Check your units to make sure that they match. So pressures and volumes need to be the same. And then remember, your temperature must be in Kelvin. Okay, so guys, we're going to go ahead and approach this problem similar to the last one. Okay, so we have a balloon here that has a volume that's equal to 3.45 liters and a temperature that's equal to 25 degrees C. The balloon is then put in the fridge, and that balloon is going to shrink down. Okay, so we have a new volume of 2,500 milliliters. Okay, and they want to know what the temperature inside the fridge is in order for us to get this new volume. Okay, so what we're going to go ahead and do here, guys, is again decide which equation we're going to use. Remember, the combined gas law, okay, can be used to decide or determine which equation we're going to use. Now, was there any mention of pressure in the context of the question? The answer to that is no, and because of that, okay, we know that pressure is going to be constant, so the equation that we're going to use is just this version, okay, that we see here. All right, now we'll manipulate this equation. We'll solve for the variable that we're looking for. Okay, so T2 is going to equal V2 T1 all over V1. Okay, and then what we're going to do, like we did last time, we're going to check our units, make sure they match. Okay, so notice, guys, I have liters and milliliters, I have two different volumes here. So again, we can use Kevin Hates dates, or we could do the dimensional analysis. Okay, but basically this is going to give you 2.500 liters. Okay, remember our temperature must be in Kelvin, so we're going to show that we're adding our 273.15, and that's going to give us 298.15 Kelvin, okay, as our temperature value there. Okay, we're going to go ahead and plug those variables in. So T2 is going to be equal to 2.500 liters times temperature 1, which is going to be 298.15 Kelvin, all over 3.45 liters. Okay, we go ahead and we plug this into our calculator. That's going to go ahead and give us 216.05. Okay, significant figure-wise, right? We got 3 here. Okay, we got what? 4 here. Okay, we got 3 there. So sig figs is going to be to the third digit here. So 216 is going to be our final numerical answer. Liters and liters cancel. Kelvin is what we have left over, which corresponds to the temperature inside of the refrigerator. So as you guys are doing these problems, remember you want to keep an eye on a couple things. First of all, guys, you're going to write out your variables. Okay, keep them grouped and labeled. Okay, V2, T2, V1, T1, etc. Okay, you're then going to utilize whatever variables are provided to decide what version of the equation you need to use. Okay, so if pressure is constant, you drop pressure. If volume is constant, you drop volume, etc. Okay, you're then going to manipulate your equation like you see here. Okay, you're going to plug in your variables for the actual values with their units. You're going to calculate utilizing sig figs and get your final answer with the appropriate units.